model based on these equations. So we have this block, then we are going to create this one. So go to the file directory, get sensor file directory, then open this MDL file. It will take a while to open the Simulink MDL file. Just be patient. Wait, be patient means you don't need to click on anything. Just be patient. Okay, in this Simulink window, we have library. You can click on library browser. Be patient, just wait. In this library browser, you can drag any component to the window for you to create your Simulink model. Okay, can you resize this window and put the library on the left and put this on the right? So resize. And make this one occupy 2/3 of the monitor, and this one occupy 1/3 of the monitor. Okay, in this one, we have a subsystem. We have sum minus block. We have source. We have monitor. And we have the output port, output port, output port, output port, output port. So the result of voltage, temperature, power, and resistance can be exported to your MATLAB workspace. Then you can plot your result. You can save your result to text file. Then you can double click on this one, subsystem. In the subsystem is another block diagram. We have input port. This is output port. You see the arrowhead. And output port. And input port, PC input. So we have one input, output 1, 2, 3. So yeah, go back to this one. See, for this, we have input port, PC, input port voltage, output 1, 2, 3. So can you go back to double click on this one? So we have input PC and input voltage here. So input 1, input 2, and output 1, 1, 2, 3. Okay, click on the PPT file. Okay, so this is a subsystem for the filament. For the filament, we have this input, and output. And the relation between temperature, Tm, and the resistance R, we follow this equation. R times 1 plus 2/3 times TCR times U1. So U1 means input 1. So if you have one input, if you have more than one input, you can have U1 for this one. Another input, U2. So this is the equation we used. And this is an integrator. So if this is Tm dot dTm dt, after this integrator, we will have Tm. And Tm dot, so Cm plus V squared over R minus Tm over R. Remember, this is dTm dt. So dTm dt here. dTm dt equal to Tm divided by Rc minus C. This is minus, this is Tm. So Tm divided by R get in. And this is OP with gain 1 over the R, 1 over CTH. So this signal Tm divided by R minus Tm divided by R divided by C enter this one. So Tm divided by R here minus here divided by C here. Okay, so this is first item. For second item, V squared divided by R. V squared here. This is V squared divided by R plus V squared divided by R divided by C divided by C. Okay, then the third item, PC plus divided by C divided by C, entered it. So at this point, we have dTm dt include item 1, item 2, item 3. Raise your hand if you understand. And for both of you, TA, go, yeah, please help both of them. Here, can you click on full view? Water. How is the server? Then let's go back to Simulink. So, for example, for this one, you can drag in source PC. So you can go to, so this is the main link. And we have sources, so click on sources. Yes. And you can look for the input port. Yeah, scroll down. Okay, input port in 1. So you can drag this one to this window. Yeah, put it there. So look, if you want to flip left to right, so right click on this one. And you can select rotate and flip, and select flip block, yes. Okay, so you can turn the direction to this direction. Okay, for this one is the summation. So you can go to MEMS operations. MEMS operations is over METHOPERATIONS. Yes, click. You can select the summation. Yeah, this one is the summation. So you can drag this one to this window. Okay, then you can click on this one. Right click. Right click. So you can flip, rotate and flip. Flip block, okay? But you need minus, plus, plus. This is plus, plus. So you can double click. So double click, you can add one minus sign before the two plus signs. So move your cursor. Okay. Minus, yes. So, okay. So you can have one minus, plus, plus. And if you want to drag the signal line, you can left click. No, left click on here and hold your mouse and yeah, release. So you can create this signal line. And how can you create? Okay, for example, this is multiplexer. You have two signals gets in. So this multiplexer have the two signals. So you can double click. So we have two input. So you can change this number. You can add much more signals if you want to have more signals. Okay, cancel. And this one is the equation. Double click. So this equation, you can type U2 squared divided by U1. U2 squared, so this is U2. This is U1. So U2 is the voltage. U2 squared means voltage squared divided by U1. U1 is this one, resistance. So this is voltage squared divided by resistance. Okay, cancel. And this is another equation. Double click. See, RO left parentheses 1 plus 2, 3 TCR U1. So U1 is the input of this one, but RO and TCR, those are the variables we defined. So cancel. And go to the MATLAB file. Go to the file directory. Lecture 10. And open this text file. This one, text file. Right click. And notepad, please. Yes. And increase the size. Control plus. Yes. So this is the the main function. The main. We can see, you can define all the variables you need. And you can do some manipulations. Okay, scroll down. See, you can call. So this command, SIN, we run this program, F23_2M. It is .mdl file, but this is legacy version of MATLAB. In the new version of MATLAB, they have .slx, but still, it's okay. We can use the legacy version. Okay, so now, can we go back to Simulink? Okay, can we go back to this F23M? So you can take a look at all this. You can go to commonly used blocks. So we have, this is the multiplexer, means you can, so this is multiplexer, we use this one. And we have all, okay, can you scroll down? Okay, you have subsystem, and you have equation, you have integrator. So these are the commonly used blocks. But you can go to, we have lookup table, model. You can look for what you need from the menu here. Okay, so do you have MATLAB installed on your PC? MATLAB. Okay, so now please install your MATLAB on your PC, then create this main function and this subsystem. Can you double click on this subsystem? Yes. Okay, this subsystem is very simple. The error between set point and the feedback signal, we take the error is the input, then go to this, multiply by this constant Kp, and this one is saturation. So saturation, double click. So this is the maximum output. This is the minimum output. So we put this one means because times Kp, if the error is large, the Kp multiplied by this error, the output signal will be large. If we don't have this saturation, this numerical analysis may fail due to convergence problem because the number might be too large and make this system. This analysis number just go unstable. So we artificially add this saturation to make the system can run. Okay, so cancel. Okay, go back to this main function. Okay, so this one is the monitor. It's not necessary, but input port and output port are important. Can you go to this? We have 3. So 1, 2, 3, 4. Can you go to this file? Yes. Can you scroll down? Okay, let me control this mouse. And for this set point from 200 to 600, increment 10, for each set point, we run this simulation. And we have output port 1, 2, 3, 4, voltage, temperature, TMP. Remember, use the same name, voltage, TMP, power, resistance. This is time. And you need to include this state variable. It's required, state variable, TX. Please go back to the Simulink. See, this is the name we used, voltage, TMP, power, and resistance. Can you double click on number 4? See, you put the name here, signal name, resistance. Okay, so now everyone, please go back to your PC and install MATLAB and create this main function and these 2 subsystems. You can follow the name I used here. And so your lab is in, so you can stay in with Kumail to run this, okay? So now the time is 1:37. So I have the 2 TA. Well, you need to create this subsystem. If you have any problem, come back here. I will help you. Okay? So I hope everyone can do this before we keep going to our next part. Okay, so